Well, dear students, in this video, I will be explaining you the spectral distribution of black body radiations, and here also Wien's displacement law. Sorry, spelling. Now, I told you what is black body. Basically, black body absorbs all radiation falling on it. But when a black body is heated and when it is cooled, then this emits radiation of all possible wavelengths within the range. I told you sun is also treated as a black body because it is emitting all radiation from ultraviolet to infrared radiation. No radiation absent within the range. Actually, radiation have wave character, and we study them wavelength wise. You will learn about what is wavelength, distance traveled by wave in its time period. I will be telling you while teaching you chapter of waves in class 11 as well as 12. So how to produce black body? I told you a hollow chamber of metal. A hollow chamber of metal may be having a narrow hole, maybe to a black body. So who studied Lamar and Prince Heim in 1899. Studied the radiation emitted by black body, and they measured the energy carried by radiation wavelength wise. Yes, so Lummer and Prince Heim in 1899 studied the energy carried by radiation wavelength wise. They took here electrically rich chamber of metal as a black body. Electric heater is placed inside a chamber, and from that chamber through narrow hole, all possible radiation are coming. Black body is perfect radiator, means it emits all radiation. Now these wavelength radiation are falling on mirror M1 from where after reflection the radiation are allowed to pass through slit S, narrow hole को slit बोलते हैं. Now this slit S lies at the focal plane of mirror M2. If light fall through focus after reflection become parallel, so parallel beam is obtained. Why the parallel obtained? This is because a prism produce pure spectrum when parallel light. You know, it is the longest wavelength, shortest wavelength at 2 points, and all possible color are in different direction. Not only two, it is a beam. Every radiation in the beam is refracted longest wavelength, shortest wavelength. Now after reflection from mirror M3, they get focused at this borometer. This received wavelength wise. Now by rotating this mirror, we can focus a particular radiation falling on the bolometer. By rotating the mirror M3, we can focus the radiation wavelength on this bolometer. Is that clear? So when radiation fall on this bolometer is a thermocouple, produce a potential difference. That potential difference measured by galvanometer, and the deflection galvanometer is proportional to intensity of radiation or energy carried by the radiation. So this way, Primheim and Lummer in 1899 studied the wavelength by distribution of radiation. Now I am rubbing this diagram because I have to do something. Lummer and Primheim heated the black body at 4 different temperatures, and then they plot the graph between wavelength and energy carried by wavelength at different temperature black body. They heated the black body 4 different temperatures, and the graph obtained were like this. At low temperature T1, at low temperature T1, then temperature raised, it was obtained like this at T2, and then at T3 like this. Here T3 greater than T2 greater than T1. From these curves, you can read book, please. It is possible, not possible me to write the special notes. You can read in every book. These graphs are given. This is important factor. All quantum mechanics came after this study. The wave at a given temperature, the energy carried by wavelength increases as wavelength increases and become maximum. The wavelength around which maximum energy carried by radiation depend on this lambda m. As temperature increases, this lambda m decreases towards short wavelength like this. Now, what are the observations? Number 1. Number of observation, area under the graph between Q lambda and lambda gives the total energy radiated within a wavelength range. So total amount of energy radiated, calculated. This energy, total energy radiated, which is equal to here under the graph, is found proportional to absolute temperature of the body, and hence Stephen law is verified. This is important thing here. Okay, by this study we can verify. Now, third thing. So, as wavelength, as temperature of black body increases, the wavelength around which maximum energy is radiated, or you can say maximum radiant energy. You can say like this: maximum radiant energy. Radiant energy. As temperature of black body increases, the wavelength around which maximum radiant energy lies shifts towards shorter wavelength. In such a manner that lambda m into t is equal to b, where b is constant, where b is a constant quantity. Constant quantity. Wien established this fact. In 1896, and here constant B is equal to 2.9 into 10 to the power minus 3 meter Kelvin, and the equation lambda m into t equal to 2.9 10 to the power minus 3 meter Kelvin is called Wien's displacement law. Wien displacement law, very important. The maximum amount of energy emitted by sun lies around wavelength of 4753 angstrom. Maximum amount of energy emitted by sun यानी कि that is lambda m for sun is 4753 53 angstrom. Angstrom, you know, 1 angstrom, 10 to the power minus 10 meter. Putting this value of lambda, so using Wien's displacement law, we can estimate the temperature of sun. कैसे भाई? ये लैम्बडा एम 4753 10 to the power minus 3 lambda into t means minus 10 into t is equal to 2.9 into 10 to the power minus 3. So from here we get temperature of sun nearly 6100 Kelvin. So this law help us to study the temperature of different stars sitting on the earth using Wien displacement law. We can estimate temperature of stars. Actually, you have seen when you heat iron at low temperature, iron emit radius longer wavelength which are invisible. As temperature rise, it becomes red and then yellowish white, and when it melts it becomes milky white, because at very high temperature it is emitting all possible wavelength. White light consists of all possible wavelength radiation. You will learn the light in class 12 and about wave. Actually, don't get afraid what is wave. I will tell you, but remember these things. Radiation, heat radiations means the energy transferred from hot body to the receiver without medium through radiation, and these are the electromagnetic waves of wavelength varying from 7000 angstrom to few millimeter, which transfer energy in the form of heat. So I have completed conduction, convection and radiation. Please read it again and again from different books. If you don't understand, please see with the video. अरे आ बेटा, sorry बच्चों, I was called by someone. So all this thing about radiation, please work hard, learn again and again, and like my video, share my video, ask your friend to subscribe my video. Now you will be getting next chapter. I will be doing first some numericals regarding radiation, and then I will start next chapter thermodynamics, which is very important.